Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 16 from the Pure Mathematics, paper 2, 0580. This is the IGCSE specimen paper from the new 2025 syllabus. This is specimen paper B, and this is the non-calculator paper. So it says P to Q is equal to 3, -1, and Q to R is equal to 1, 9. Work out the length of P to R. So before we can find the length of P to R, we need to find what the vector P to R is first. Okay, so we need to find the length of the vector P to R. Can we get the pen sorted out? So the length of P to R, that's what we need to work out first. Now, we need to work out, the vector P to R before we can find its length. What we can do here, I don't really need to show a diagram. It's very easy to do this without a diagram, but just to illustrate it to the students exactly how to do it, or how we can picture what's going on, that might be useful. So P to Q is 3, -1. Okay, so the column vector 3, -1, the top number tells you how to move to the right or horizontally, and the bottom number tells you how to move vertically. So the vector 3, -1 is like, if you start from here, it's like you're going 3 spaces to the right and 1 space down. So the vector P to Q would look something like this. Okay, vector has a magnitude and a direction. So this would be the vector from P to Q, something like this. That's P, that's Q. 3 units to the right, 1 unit down. And Q to R, okay, Q to R is 1 unit to the right and 9 units up. So it's going to be something like this. Something like that. That would be Q to R. It's just a rough kind of diagram. So P to Q is 3, -1, and Q to R is 1, 9. And what we're asked to find is the length of the line from P to R. So first of all, finding the vector P to R would be what we need. Now it's pretty simple to see that if you want to go from P to R, you can go from P to Q and then Q to R. So this is like going from P to Q and then adding to that Q to R. That will get you from P to R. Okay, we could do that. We could think about that without even drawing the diagram, but this just illustrates it for us. So P to Q is 3, -1, and Q to R is 1, 9. So when you want to add these two vectors together, you simply just add their components. So 3 + 1 is 4, -1 + 9 is 8. So we have the vector, okay, taking you from P to R is going to be 4 and 8. How do you find the magnitude of that vector, the length of PR? The length of PR would be the magnitude of the vector PR. Okay, and that's found by Pythagoras' theorem. If you think about, a line, which is this is 4 and this is 8. Okay, so it's not very well drawn. This is 4 and this is 8. Okay, and we want to find the length of this line. This is 4, this is 8. We can use Pythagoras' theorem basically. Okay, to find the length of this line, it's going to be the square root of the square of these two sides. So it's going to be the square root of 4 squared plus 8 squared. Remember, this is a non-calculator paper, so we have to be able to give our answers without using the calculator. So that's 16 plus 64. We should know our square numbers. That's going to give you the square root of 64 plus 16. That's going to be 74 plus 6. That's square root of 80. Right now, of course, that's not going to give us an exact value. We're not to write it as a decimal because we are not to use a calculator, but what we should do is write it in simplified surd form. So you look for 2 perfect square numbers in 80. I think 16 times 5. Is that right? Yeah, 16 times 5. 16 times 5, that's going to be 30 plus 50, which is 80. Okay, so it's going to be 16 times 5. We could break it down smaller. If you weren't sure about 16, you could have tried, for example, 4 times 20, and then 20 has another 4 in it. You could have done it slowly, but this will give us the answer as 4 times √5. Now, this is the answer in its simplified surd form. That's the length of PR. Okay, if you wrote it as √80, really it should be given as 4√5 because it should be simplified. I don't know if they would accept that in their mark scheme. I'll just have a quick look and see. Okay, so I've checked the mark scheme and it does say √80 or equivalent. So you could leave it as √80 and that's fine. But in general, it's best to write things in their simplest form. And with surds, the simplest form is when you have taken out any perfect squares from the, square root. So this is acceptable. This is a more complete answer, but they would accept that in this question. Okay, so there's the answer to question number 16. Other questions from this paper can be found in the playlist, which will appear on the top right of the screen at the end of this video. Other questions from the topic of vectors from my new syllabus material can be found in the playlist at the bottom right of the screen. You can find other questions from vectors from the older pre-2025 papers in the playlist over here that will still be relevant to you. And you can subscribe to my channel by clicking on the link at the top. Thank you for watching and see you soon.